Welcome to this presentation on building a scalable GraphQL gateway with federation and DataLoader in Node.js. We'll explore topics such as understanding federation, the N+1 query problem, introducing DataLoader, how DataLoader works, building a user's subgraph, building an order's subgraph, creating the gateway, querying the gateway, and further resources and references. Federation allows us to merge multiple GraphQL services into a unified supergraph. It distributes the ownership of types and fields across these services, enabling collaboration. The key directive is critical for uniquely identifying entities, ensuring seamless integration. Moreover, type extensions let us link related data effortlessly across services, enhancing our schema's flexibility and usability. N+1 queries occur during nested field fetching, leading to performance bottlenecks. For instance, fetching one user could trigger 50 additional queries for their orders, resulting in a total of 51 calls. This inefficiency highlights the need for batching and caching strategies to optimize data retrieval and improve overall performance. DataLoader is a powerful tool that batches multiple requests into a single API call, which drastically reduces the number of calls made to the backend. It also caches results during a single GraphQL request, ensuring that repeated queries for the same data are served quickly. This caching is essential for maintaining high performance, especially when dealing with nested queries. By minimizing redundant calls, DataLoader enhances the efficiency of your GraphQL gateway. DataLoader begins by being instantiated with a batch loading function. As requests are made, it collects them efficiently during execution. Only after gathering all user IDs, it dispatches a single batch request. Finally, it distributes the results back to individual resolvers, ensuring optimal performance and reducing the number of calls to the database. To build the user's subgraph, we start by defining the user type and its associated queries in our GraphQL schema. Next, we implement resolvers that fetch user data efficiently. Utilizing Apollo Server alongside federation tools allows us to create a cohesive and scalable architecture. Here's a simple diagram illustrating the connections between these components, which also sets the stage for our example code for the user service. To build an order subgraph, we start by defining the order type and necessary queries within the GraphQL schema. Next, we extend the user type to include a relationship to orders, allowing us to fetch orders related to a user seamlessly. Implementing resolvers is crucial for retrieving the order data efficiently. The diagram illustrates these components and their connections, leading us to a working order service setup. To create the GraphQL gateway, we start by setting up the Apollo gateway, which composes our subgraphs. We then integrate DataLoader to optimize data fetching, ensuring efficiency and speed. Service endpoints will be configured for both users and orders, allowing seamless data access. The code snippet will help illustrate how to initialize the GraphQL gateway, bringing it all together. Querying the gateway involves a client requesting users and their associated orders. The request flow starts at the client, which hits the gateway. Here, we utilize DataLoader to batch order requests, effectively solving the N+1 problem. This allows us to gather all necessary data in fewer calls, enhancing performance and efficiency in data retrieval. Explore the Apollo Federation and DataLoader documentation for deep dives into essential concepts. Check out additional tools for schema stitching to enhance your GraphQL architecture. Consider managed GraphQL services to simplify your setup. Finally, I encourage you to learn and experiment with scalable architecture to truly harness the power of GraphQL.